Okay, YouTube, in my last couple of videos, we've been talking about how we can graph equations in the XY coordinate plane. In this video, I just want to focus on what we refer to as intercepts. So we're going to define them here. We say that intercepts or graphs are points at which our graphs intersect either the x-axis or the y-axis. So you'll notice on the right here, essentially I've got a screenshot of this graph y equals 4 minus x squared. If we were to find solution pairs for it and sketch it in, we would say that this is the graph. But what I want to point out here is that it has several intercepts. We say that it has two x-intercepts where it runs into the x-axis here, and it has one single y-intercept. Not all graphs have this, but you'll notice that the way that these intercepts are listed here, it just says x-intercept is -2, and x-intercept is +2, and y-intercept is 4. So the interesting thing about listing intercepts is that sometimes if I were to write an x-intercept, okay, so x-intercept like this, we would be able to write it as like maybe -2 and 2, and we say y-intercept. Okay, we can say the y-intercept here is 4. We're often used to writing points as ordered pairs though, okay? So just know that when you're writing intercepts, this is acceptable to just leave it as a value. But what I'm going to say is that it's most often probably appropriate to write an intercept as an ordered pair. So not only would I just write this as -2, I would say that this is the point -2, 0, and this is the point 2, 0, and this point up here would be left and right none, but up 4, okay? So really quickly, let's go ahead and say, could we identify the intercepts for the following graphs and list our responses as ordered pairs x, y? Well, I notice that all three of these are linear equations, and this one here looks like that it has an x-intercept at -3, 0, and we say a y-intercept at 0, 5. So it's appropriate to say, we'd say x-intercepts, y-intercepts. We can just list them this way. We say -3, 0. We say 0, 5. As far as x-intercepts go here, we would say that the x-intercepts, we could just write none. This never intercepts or intersects the x-axis, whereas the y-axis, it looks like we have one y-intercept, and it's this point here, and that would be the point 0, 4. And then lastly, we've got this here, which is an interesting one. You say, what's my x and my y-intercept? Well, they're both 0, 0, okay? It hits the x-axis and the y-axis at the origin. So the last thing I'll point out here is essentially this, the different types of intercepts, but you just see a whole list of functions here essentially. And they have different types of intercepts. So you'll notice that this is a downward opening parabola. It has one y-intercept here, whereas this sideways opening parabola has one x-intercept. We could have a circle. It could certainly have no intercepts. Or we could have something that's not a function, but this like sideways cubic looking thing here. It has 3 y-intercepts and a single x-intercept. And then this last one here, just remember, if it ever hits at the origin, it's classified as both the x and the y-intercept. Cheers.